yes, the graphics in game trailers looks amazing, but when it runs on your computer, it looks like crap. And today, we're gonna talk about it. Most of the time, when your game is laggy, it's because your computer is doing too many calculations and rendering too much triangles at the same time. There are many other ways to render the scene, such as using voxel, but today we're only going to talk about triangles since it's the mainstream way to do it. In this case, I made a low poly tank, which is 3D. It's also made in Blender. As you can see, it has 2,000 something vertices and 4,500 triangles. So what we want to do is, when we are closest to this mesh, we want it to render as much detail as possible. While we take a step back, we want to render less triangles and vertices. And when we get super further back, like at the other side of the map, we want it to render just a billboard. So basically it's a plane that will face the camera, it will face the player all the time. And here I copy pasted into two different models. I slapped a decimate modifier onto those. So basically what it does is it reduces all these things to 0.7%. Look at this one. It has less vertices and less triangles. Then you look at this one. It has even less vertices and triangles. So what we want to do with those is, when we are closest to the mesh, we choose to render this one, the one with the most detail. And when we get back, when we take a step back, we choose to render this one, the one has less detail. Let's see how it works in Unreal Engine. So in this case, we downloaded a mesh from Megascan, and it's a rusty car exhaust. We can double click on it, and we can see that it has 5 different LODs. When we get closest to it, it will render LOD 0, which is the one that has the most triangles and most detail. When we take a step back, oh my god. Okay. When we take a step back, it will render the second level of detail, and has half the triangle and half the vertices. Take a step back, and you get a drill, right? So like the further you are away from the mesh, the less triangle it's gonna render through using this technique. And let's take a look in game. As you can see, it is actually swapping between different level of details, but you can't really tell because the artist did a really good job on this static mesh. However, in some other games, when you turn the graphics quality down, you will be able to tell the difference. For example, when I was playing Genshin Impact, the swap was very easy to tell when I was running on the lower graphics setting. The artists have to make multiple level of detail of the same objects and make sure they transition seamlessly, that you cannot spot the flaw while playing the game. It was exhausting and took a lot of time. But guess what? Daddy is here. Unreal Engine 5 introduced another way of rendering this static mesh, which is called Nanite. You don't need to read the source code like I did.
Don't get worked up again.
All you need to know is that it generates different level of detail in real time and swap them based on the distance between your camera and the object. On the same static mesh, we can enable Nanite support. Let's apply changes to it and save it. And it will be rendered through Nanite. So let's light it up. Let's take a look. We can enable Nanite visualization and show all the triangles. It works basically the same way, but you don't need to generate the level of details manually. The Nanite does it for you. When you take a step back, get further and further, it will be rendering less triangles and less clusters. It works perfectly fine on most static meshes, but what if we apply to meshes that can deform and move in the world? For example, this. Okay, so the answer is no, it will not perform well. Because what Nanite does under the hood is it will group triangles into clusters. Each cluster would have 128 triangles by default. This technique optimizes performance by merging these clusters real time. However, on meshes like trees, in order to preserve the accuracy of the models, we choose to not merge the different clusters of the leaves and branches. Swaying leaves, bending branches, and animated wind effects would make it challenging for Nanite to optimize and stream the required geometry efficiently. By doing so, it defeats the purpose of using Nanite for optimization. But is there another way around? We can, besides using the traditional level of detail, we can also use another method called imposter. Here is the level I built to display 4 different foliages type. The first one was the world position offset foliage with dynamic shadow, what we were talking about all along. So basically what it is its leaves are moving, the shadow is moving as well. But since we're in, I think it's medium rendering quality, the graphic quality is pretty low right now, so you can't really tell. But once you turn it up, you can tell like all the leaves will be moving instead of just the little ones on the edges. And this one is the static foliage with static shadow. We will be using this one as the imposter to improve performance later on. This one is the world position offset foliage without shadow. So basically it's dynamic, but it's not casting any shadow. What our final goal of this demo is, we want to slap static shadow onto dynamic foliage. So basically we want the body of the foliage to move, but not the shadow. This is a world position offset enabled foliage with static shadow. As you can see, the leaves are moving, but the shadow does not move at all. Let me just bump up the graphic quality really quick. If you can't see really well, we can change the time of the day as well by pressing Y and U. I exposed function to allow you to change time gradually or rapidly, or simply add another 30 minutes by pressing RT, Y and U. I also set up a weather system where you will be able to swap between sunny, rainy, snowy, and cloudy weather. So here's the clean sky, here's the cloudy, here's when it rains, and this is when it snows. Alright, so I did all that just to make sure you can have a better comparison of what the shadow will look like. So let's talk about how this is achieved in Unreal Engine. Let's take a look at its blueprint. It has 2 different static mesh components. One is the tree itself, which is moving, but this one does not cast any shadow. And this shadow imposter mesh, we make it cast shadow, but make its original mesh, the tree itself, hidden from the game. So as you can see, when it's being rendered, the tree itself will be hidden from the game. And when we click on this to enable hidden shadow, it will make sure even when the mesh itself is hidden in the game, the shadow will still be casted. So this is how it is done, okay? But we don't want to use a blueprint instead of a static mesh in the game. The idea is to place the world position offsetting enabled foliage into the world first without casting any shadow. Then we add the static shadow using C++ or blueprint or other ways around. This one is world position offset enabled as well as the shadow. So basically the shadow is dynamic as well. We can take a look at the virtual shadow map. As you can see, the ground that is printed blue is not cached in the memory, so it has to be rendered real time. This map has exactly the same number of foliages as the last one, but it's not casting dynamic shadow. When we take a look, we can see none of these areas that are supposed to be blue are blue. It's because we use the imposter method. We put a shadow imposter underneath the world position offset enabled foliage tree. So this is the trick. By doing this, we'll be able to save a lot of performance, and you can playtest it. I made this really user-friendly. That's you basically just need to walk forward. The the density of the foliage increases the more you go, and it will pop up a number to show you what level you are right now. So basically 1 means the foliage, the forest have a density of 0.1, and this 2 means 0.2. So like the further you go, the more density the forest will have. You can basically just keep going. Just keep going, keep going, keep going. 5, 6. Okay, 6. Oh my god, I can't really see. Okay, it's getting laggier. And we can also swap map to go to another map. So this is the display map 2. It has the world position offset foliage with the dynamic shadow. And you do the same thing, you just keep walking. You just keep running forward. And yeah, that's pretty much it. And this is what I did in this demo to sort of let you test play it yourself. Go play it. It is really fun. And make sure you read the README as well, so you know what keys to press in order to give you the best experience. And yeah, that's it for me. Hope you liked the video and learned something from it.